Alright, hope you guys were able to see the last video. This one is actually a little bit easier. It's one me and a couple of my friends were stuck on. We worked on it for a while and couldn't figure it out. I spent a little time working on it when I got home, and naturally when no one else was around, I managed to figure it out, and I celebrated, and there was nobody there to share my celebration with me. So this is number 1. This is the same section. This is 10.4, and this particular section, this exercise, we are finding the area of the region that is bounded by the given curve and lies in the specified sector, which in this case our curve is r equals e to the negative theta over 4, and we're finding this between pi over 2 and pi. And in case you're wondering, that is basically what the area looks like between pi over 2 and pi that we are trying to find. Alright, so the first thing we're going to do now is we're going to set up our integral that we're going to be using, which is a equals from beta to, or rather from alpha to beta, 1/2 radius squared d theta. So now we can just start plugging in right away. Beta is pi, alpha is pi over 2, 1/2 e to the negative theta divided by 4, and all of that is squared. Now, when you're squaring something with exponents and it has a like base, all you need to do is just add your exponents. So it's basically e to the negative theta over 4 plus e to the negative theta over 4. Or that's not entirely accurate. The addition actually takes place in the exponents. Negative theta over 4 plus negative theta over 4 will get you e to 2 theta over 4, negative 2 theta over 4 rather, which equals e to the negative theta over 2 once you reduce it. You can see that ran a little tight on space there, but that's your r squared. So now we're going to rewrite this down here. From pi to 2, pi over 2 to pi, 1/2 e to the negative theta over 2. D theta, always forget the d thetas. So, naturally, we're going to be doing some u substitution to find our integral. So, u equals, when you have e to the whatever, your u, when you're doing your substitution, will always be whatever the exponent is. In this case, it's negative theta over 2, or we'll rewrite that and make it a little easier to use, negative 1/2 theta. So our du, you have a constant and a variable next to it, it's always going to be just a constant. So that becomes negative 1/2 d theta. So we're going to take a look at the integral the way we have it now. We have a 1/2, but it's positive. So that means all you're going to do, you rewrite this. Not going to need that integral sign anymore. The 1/2, as the 1/2 is part of the du, that's going to go away. But it's negative, so we're going to make our integral negative, and you're going to end up with negative e to negative theta over 2, and of course that is between pi over 2 and pi. Yeah, I think getting to this point was actually a little tricky before, but once I took a look at the mistakes, I practically punched myself in the face, realized how silly the mistake was. So, and if you're confused by this, if you go online and you use an integral calculator to see what the integral of 1/2 times e to the negative theta, or I guess for most integral calculators it would be x, negative x over 2. If you want to see what that is, you're going to end up with negative e to the negative x over 2. But we're using theta here, so we'll just go with that. So now we're going to plug in our bounds, which is negative e minus pi over 2 minus negative e to negative pi over 2 all over 2. So we're going to go down here, and you're going to get negative e to negative pi over 2. These negatives that you see here are going to become a positive. E, now negative pi over 2, of course you divide that by 2. You just multiply the small denominator by the larger denominator, and you're going to get negative pi over 4. And of course that answer should be acceptable by most professors, but if you want to clean it up a little bit, just put the positive in front, and you'll have e to the negative pi over 4 minus e to the negative pi over 2. And that's your answer. This one actually wasn't that bad. I guess the moral of the story is, if you work on math problems for 10 consecutive hours, even simple stuff like this is going to get complicated. But this one wasn't really that bad. And there's your answer. And I hope you found that helpful. So just don't forget to rate and subscribe. Thank you. Have a great day.